Okay, so let's discuss today's lead code contest. Although contest was not that easy, I was only able to solve the first two problem. Third one, I was able to figure out the logic, but I was not able to implement the logic. It was DP problem. So yeah, like I will absolve it, and then mm, I will figure out my mistake, like where I was doing mistake in this question. Okay, so in this video, I will be discussing the first two problem which I have solved during the contest. Uh, this was the second problem of the contest, and it has. I mean, let me with the Google Doc first, and I'll be discussing the logic of the problem here only at the Google Doc. Okay, so you have been given what has been asked in the question is that mm, you have been given two array. Let's say ARR, okay, and another array that is BRR. Let's say these are the two arrays that have been given to you, and in ARR, mm, let me explain it also. So ARR, which consists of some numbers, let's take 8. What was the test case? 8 4 3 2 4. 8 4 3 2 4. Okay, so this was the first array, and the second array was 4 2. If I'm not wrong, yeah, 4 2. So here 4 2. Okay, so this was the two array that has been given to us, and we'll have to return one array which will basically denote that let's say answer array. Will have to return the answer array, and answer array will basically represent the indexes of the number in BRR, which basically divides the number in ARR. So let me tell you what could be the answer for this test case. So this 4 divides 8, 4 and 4, right? So what is the indexes of the element in ARR which is divisible by the 4 which are present in BRR? That is 0, the 0th element, which is divisible by the 0th element in BRR, and the first element which is also divisible by the 0th element in BRR, and the final element, that is fourth element, is also divisible by let it is also divisible by let me take this as well. Okay, so here it is also divisible by 1 0. I mean this 4 is divisible by this 4, and the 4 and this 4 have the 0th index in second array, that is BRR, right? And the second element, that is 2. 2 divides how many element in ARR? 2 divides 8, 2 divides 4, 2 divides 2, and 2 divides 4, right? So the element which are present at the 0th index, the element which are present at the first index, the element which are present at the third index, and element which are present at the fourth index is divisible by the element which are present in the first index of BRR, right? If the condition was that if there are multiple elements dividing a single element in ARR, then you will have to return the element with the minimum index. So out of 2 and 4, which element have the minimum index? Obviously 4. So 8, which is divisible by 4 and 2 both. So in this case, I will be returning the index of 4, not the index of 2. So this was the condition that has been asked, that has been given in the question. So in this case, this 2 divide 8, but the 2 have the index 1, and the 4 have the index 0, and 4 also divided. So in the 0th element in ARR will be divisible by the 0th element in BRR, not by the first index in BRR, right? And this 4 is also divisible by 2, but since I will have to return the element with the minimum index, so I will be returning 0 in this case, because the 0th element in BRR also divides this 4, and this 3. 3 is neither divisible by 4, and it is neither or it is nor it is divisible by 2. So in this case I will be returning -1. So here it should be -1, right? Let me do this. Okay, and then 2. Since this 2 is now divisible by 4, right? Like no one element divides this 2 in ARR before 2 in VRR. So what could be the index here? Index is 3. So like, I mean, yeah, it is 3, no? No. First, like you will have to return the index of BRR, the element of BRR, not the element of the RR. So yeah, this was the question. So I think the question is clear to you. Let's read the statement of the question, if I am not wrong. Okay, the an element J can be assigned to the group I if group I is divisible by elements J. If there are multiple elements that can be assigned, assign the element with the smallest index that I was talking about, right? Like 4 also divides it, 2 also divides it. So in this case I will be returning the 0 index of basically the index of 4, not the index of 1, because the index of 4 is smaller than the index of 2, right? If no element satisfy the condition for the group, assign -1 to that group. In that case you will have to return the -1 that we have returned in case of 3. Okay, return the integer array assigned where assigned of I is the index of the element chosen from the group I, or -1 if no suitable index exists. Okay, so like basically we'll have to return this array, this answer array. So yeah, this was the problem. And if you look at the constraint of the problem, then it is 1five. I mean, yeah, the group dot length is 1five and elements dot length is 1five, and group of I is also 1five and element of I is also 1five. So one thing that we can do is like we can apply the nested loop, and like we'll have to we can check, like, yeah, first of keep pointer at 4, then do iterate over the ARR and then check which element is divisible by this 4 in BRR, and then at that particular index return 0, return the 0 of 4 in BRR. So in this way we can maintain answer array, right? But this is not the correct way, because if you look at the constraint, then it is 1five, and it is not acceptable in this case. So basically you will have to think some optimal approach. How will you do this? Okay, so like up to now we have understood the question, and we have understood the condition that we can't use the brute force approach, basically the nested loop approach, because of the constraint. So what next we can do? Okay, tell me one thing. If I have the if the number is if the number belongs to number is greater than equal to 1. I mean, what is the constant? Yeah, number is greater than equal to 1, and number is less than equal to 1 and if I am performing an operation, right, operation will be from 1 to square root of 1 then how many total operation I will be I will be ended up doing in this case? Like what could be the uh, how many operation I will do in worst case? Let's calculate this. Let's calculate this. So since I am performing the operation from 1 to square root of 1 so let's calculate the square root of 1 first. 1 then it could be square root of 1 and square root of 10, right? That will be equal to the square root of 1e4 is 1e2, that is 100, into let's say the square root of 10 is let's say 3.1 or what, 3.3, let's say. So it will be equal to how many 330. So if I will perform this operation from 1 to 1e5, in worst case I will be ended up doing 330 operation, right? So this is the catch of the problem. Basically, uh, if, and let's say if I am performing this operation, this OP operation 1e5 times, then how many total operation I will be ended up doing? Total operation will be total operation will be 1e5 into 330, right? So it will be equal to almost 1e7. I mean, greater than 1e7 but less than 1e8, and there is no chance to get TLE in this case. Yeah, it will be equal to 33 into, you can say, 1e7. Okay, and this is, in this case we will not get TLE, and if you are performing this much operation, then your code will be accepted, right? So basically what we can do is that we can iterate over this second array BRR, and then we can map every element of this array to its index. So let's do this. So in this case what we can do is that the 4 is lying at 0th index and 2 is lying at the first index, right? This is how, like, I will be maintaining one map data structure to maintain this map of BRR of I is equal to I. If it is not found, like in case of repeated element, like let's say in case of this comma 4, then basically the answer of this, like this 4 will divide, let's say this 4 divides x element in ARR, then this 4 will also divide x element in ARR. So I will be storing all the element which is divisible by this 4, not this 4, because index of this 4 is smaller than the index of this 4, right? It is at 0th index and it is at the second index. So the condition is that if this element in BRR is not found previously, then only we will be storing this element, like the element to its index. In this case 4, 4 to 0 and then 2 to 1. In this way we can store the things, and then we can iterate over the array ARR, right? So like int I is equal to 0, I less than ARR dot size, and I plus 1, and then what we can do is that we can pick every element of this array ARR, and then we can iterate iterate one loop from 1 to a square root of ARR of I, and then we'll check if this element is found in map or not. If this element is found, then basically we have got one divisor of ARR of I, and then after that I will be checking what is the smallest index of the divisor. Like let's say for the element 8, if we'll run the loop from 1 to 2 basically, right? Because 3 is not the, like 3, if we'll take the square root of a square of 3, then it will be 9. So we'll run the loop from 1 to 2, and then we'll check if 1 is the divisor of it or not. Yeah, it is divisor of it. Then if it is found in BRR or not, it is not found in BRR, so I will not consider it. Then I will go to 2, if the 2 is divisor of it or not. Yeah, it is divisor of it, and then I will find the index of 2, that is 1, right? And one more divisor will be here, that is 4. And how we can get? We can get 8 by the current divisor, like current divisor is 2, so I will be doing 8 by 2, that is 4. If this 4 is found in BR or not? Yeah, it is found. Then what is the index of this 4? That is 0, and which is just smaller than the previous one. What was the index of 2? that was 1. So basically in this case I will be taking the 0th index. So basically what I will be doing is that I will be iterating over the array ARR, and then I'll be doing one more iteration from 1 to square root of ARR of I, and then I will be finding if this divisor is present in a BRR or not. If it is present, then I will be finding the minimum index of that particular divisor. In each and every operation I will be doing this, right? And then I will be storing the I will be maintaining this answer array, and at the end I will be returning this answer array, return answer. So this is how I will solve this problem. And talking about the time complexity, so which we have already discussed. In worst case, the time complexity will be 33 into 1 is 7. That we have already discussed, right? So which is basically equal to how much time? N into square root of maximum element of the ARR, right? We'll tell you the time complexity of this code. Then N into square root of max of AR of I. Okay. Okay, let me see if it is recording or not. Okay, okay, it is recording. So yeah, this we can do, right? And talking about the space complexity, we have taken the space of map. In worst case, it could be big of n type, right? Because if all element of the BRR is distinct, then we'll have to return we'll have to store the n element, and basically every time we are storing the pair, so twice of n. So like we have that much space complexity. So yeah, this was the second problem, and if we'll see the solution, then so this was the solution that I have implemented. So basically what I took is that I took one map data structure which will basically store divisor to index, basically the index of second element BRR. uh, okay, and then I have taken one vector v, which is basically the answer vector in this case, and then like I am iterating from 1 to square root of group of I, and then if it is divisible, then I will be finding this element in the divisor to index, and then I will also finding the group of I by d into divisor to index, and then if it is available, then I will be just maintaining the minimum index, and then I will be assigning that particular minimum value into the answer array, and then at the end I will be returning the answer array. So this was the solution of the first question, and it was pretty simple solution. Like it was very cool solution. I mean, you don't have to do any extra thing. Like initially, while I saw this problem, at that moment only this logic has stuck in my head. But like while implementing, I made some mistake, and yeah, that is bound to happen. Okay, let's move to the first question. So this was the first problem. Hmm. The problem was you have been given 2D grid, right? You have been given one 2D grid, and you will have to return a resultant grid, which is basically the modified grid of the previous one, such that this is the middle diagonal. This is the middle diagonal. The element, the diagonal which is above this middle diagonal should be sorted in increasing order, increasing fashion. Like you can see above this diagonal, which is basically the middle one, there are two diagonal which consist of the elements 7, 2 and 3 respectively. So they are sorted in decreasing order, but they should be sorted in increasing order like this way. It should be swapped 2 to 7. And like while element or the element which are present in the diagonal of this matrix below this diagonal, including this diagonal also, like below the middle diagonal, including this diagonal, should be sorted in decreasing fashion, decreasing order. So like you can see this middle diagonal which consists of the element 186, then it should be 861, and then 9 5 it is already sorted in decreasing order. So like this was very easy problem. So basically what I will be doing is that uh, I will be like I will be iterating over this uh, each and every row, right? And basically I'll be taking the each and every element of the diagonal. I mean, it was my like I implemented this problem in this way. Like I can take all the element of every diagonal by this way. Like I had done, I have made one function it to take all the element of the diagonal, right? Which is available below this, including the middle one. And then if it is below, if it is below the middle diagonal, then I will sort the diagonal in increasing order, or I will sort the diagonal in, if it is not, it is above, then I will sort the diagonal in decreasing order, and then I will be assigning that particular element, all the element in the diagonal uh, of whose value is equal to this. It should be uh, this available in the diagonal array, like what I made one, yeah. And then it should be diagonal. Like I was modifying, I had written very weird code, so like I was improving the readability of my code. So while doing that, I left it was like diagonal. It should be dia array that I have made here. Okay, so like I will be assigning the value of the sorted array into the matrix, into the modified matrix in this way, right? And yeah, this is how I have taken the value. So like how will you decide ki the element that you are taking in the dia element is below the diagonal, middle diagonal, or including this middle diagonal? How will you do this? Basically, if you iterate from this array, from the zeroth row, then you are also always going to, like if I am at the zeroth row and zeroth column, then I will be going to the first row and first column, and then I will be going to the second row and second column. So basically I have taken this element. And if I will start from the second row, if I am at the first row, then first row first column, first row zeroth column, and first row first column, and then done, we have taken the 9 5. So in this way we can do, and this is what I have done here. And how will you take the element which are present in the diagonal above the middle diagonal? So we'll start it from the j is equal to 1, right? So the row should always be 0. I mean, we'll start the our iteration from the 0th row, and then we'll increase this. I mean, the first column 0th row, second column first row. So in this way I will accumulate all the elements which are present in the diagonal above the middle one. And like if it is above the middle one, I will be sorting it in the increasing order. If it is below the middle one, including the middle one, I will be sorting it in decreasing order, and then I will be assigning that decrease modified value into the matrix, and then at the end I will be returning the matrix. So this is how I will be solving this question. So yeah, I don't think you need explanation in this question as well. This was very easy one. So yeah, okay, thank you.